mi yi divided by sigma mi. This is the formula to determine the y coordinate of center of mass. So in this case, m1 is first mass m, whose y coordinate is 0. Similarly, second mass is 6m, whose y coordinate is also 0 because both of them are lying on the x-axis. And third particle mass is 3m, whose y coordinate is a. Fourth particle is 4m, whose y coordinate is a, divided by total mass. Once again, same thing, 6m, m6m plus 3m plus 4m. From this, what we conclude is, these two are zeros. This is 3ma, 4ma, 7ma. 7ma divided by, this is 14m. So, a by 2. Y coordinate is a by 2. So, therefore, center of mass location is, center of mass coordinates are the earlier coordinate xcm and ycm are the coordinates of center of mass, location of center of mass. Location of center of mass. So, center of mass location can be calculated for individual particles which are discrete here, where we can make out the particles and their locations, then individually we can calculate. We will take one more example and see how can we calculate the center of mass of a discrete system. So, let us consider particles at the corners of an equilateral triangle. Let us consider an equilateral triangle. Okay. The side length of this triangle be A. A is the side length. A. Let the particles be located as shown, x and y axis. Let it be m. 2m may be at the midpoint of this side, 3m at the topmost point of the triangle, and let be another point at the midpoint of this side be 4m, and this is 5m, and midpoint of this be 6m. So there are altogether 3 to 5, 6 particles. They are at different locations on the triangle. These 3 particles are at the corners of the triangle. These are at the midpoints of the sides. Like this, the particles are there. So, how to calculate the center of mass in this case? Since the mass distribution is on the xy plane, we will have x coordinate and y coordinate as the coordinates of the center of mass. There are 2 coordinates of the center of mass. Before we go for the determination of center of mass, first we have to locate the individual coordinates of the particle. This particle is at the origin, therefore coordinates of this particle are 0, 0. This particle is on x-axis at a distance a by 2. This distance is a by 2 because total side length is a. Therefore, coordinates of this point are a by 2 comma 0 because it is on the here at a distance a by 2, since it is on x-axis, y coordinate is 0. Similarly, coordinates of this point are a comma 0, and coordinate of this point is the x coordinate. X coordinate, this total distance is a, this angle is 60 degree. Therefore, this distance is a cos 60 degree is this distance, which is nothing but a by 2. It is exactly on this, it is there, x coordinate is a by 2, y coordinate is a sin 60 degree. A sin 60 degree is a into root 3 by 2. Sin 60 degree is root 3 by 2. Therefore, a root 3 by 2 is the y coordinate here. Now we are able to determine the coordinates of this. Now these are the 2 particles. These 2 particles case coordinates of this particle. X coordinate is, this distance is a by 2 cos 30 degree. A by 2 cos 30 degree is a by 4 cos 60. A by 2 cos 60 is a by 2 into 1 by 2 is a by 4, and a by 2 sin 60 degree is root 3a by 4. So these are the coordinates of 2m. And what about the coordinates of 4m? 4m coordinates are this distance. This distance is a by 2, this is a by 4, 3a by 4, it comes out to be x coordinate. Y coordinate of this and this are same, that is root 3 a by 4. So like that, first we will find out the coordinates of individual particles. Now we are able to identify the particles and are able to locate them. Therefore, this system is discrete. That is the reason why this system is called a discrete system. And now, how to calculate? Since that system is distributed in xy plane, as I told you, we can calculate both x and y coordinates of center of mass. Now we will find out xcm. xcm, as per the definition, it is mi xi by sigma mi. Therefore, m1 x1, m1 is m into 0 because it is at the origin, and we go in this order. So in this order we go, then plus 2m into x coordinate of this is a by 4 plus 3m into x coordinate is a by 2, 4m into plus 4m into x coordinate is 3a by 4 plus 5m into x coordinate is a plus 6m into x coordinate is a by 2, divided by total mass of the system m plus 2m, 3m plus 3m, 6m plus 4, 10m, 15m and 21m. That is, total mass of the system is 21m, and we will be able to calculate. So this is 2 by 2 and this 4 gets cancelled, this 3. So therefore we have ma by 2 plus 3ma by 2, 3ma by 2 plus ma by 2 is 2ma, 2ma plus 3ma, 5ma, 5ma, 10ma plus 3ma, 10 plus 3, 13ma is the numerator, divided by 21m. So 13a by 21 is the x coordinate of center of mass. Similarly, y coordinate of center of mass, we can calculate ycm is equal to sigma mi yi by sigma mi. This is the formula. From this, what we can write is m1 y1. m1 is this mass, y coordinate is 0. Therefore, m into 0 plus second is 2m. 2m y coordinate is root 3a by 4 plus 3m y coordinate is root 3a by 2. 4m y coordinate is plus 4m into y coordinate is root 3a by 4 as it is of 2m. Then 5m y coordinate is 0. 6m y coordinate also is 0. Total mass is 21m. And from this, this is 0, this is 0, this is 0. Only these three particles will have y coordinate of center mass contribute. This is 2 times. Therefore, what we will get is root 3am, root 3am, root 3am by 2 means 3 root 3ma by 2. This is root 3. Therefore, what we will be getting is root 3a by 2 when we take common. Root 3a by 2 we got in all the three terms. Here we have m plus 3m by 2, m plus 3m, m plus 3m plus 2m. 3 by 2 means 2 by, this is 2m. This comes out to be 3 root 3, this is 6m, 3 root 3a, this divided by 21m, 21m, m gets cancelled, 7, root 3a by 7 is the y coordinate. X coordinate of center of mass is 13a by 21, y coordinate of the center of mass is root 3a by 7. That's how we calculate the center of mass for discrete system. Now we will see how we can calculate for a continuous mass distribution. For continuous mass distribution case, okay, what is meant by continuous mass distribution? It is also a system of particles, or mass is distributed in the form of particles, but particles are so minute and so close that we will not be able to locate the individual particles and their masses. Therefore, we cannot make out the individual particles. For example, we have a coordinate system like this and system of particles like this. So there are many particles, very tiny particles are within this. We know that there are many particles. Particles are so small, it is very difficult to identify the individual particles. In such situation, what we do? We imagine this be divided into small elements. Let us consider mass of that element, small infinitesimal mass. Imagine that given distribution be divided into infinitesimally small elements. Consider one infinitesimally small element as dm. So though it may contain the particles, but we imagine that as a single particle. Imagine that as a single particle. Let R be the position vector of that particle. Let R be the position vector of that particle, ith particle, Ri element, or R is the position vector of that particle. Then center of mass of the system is integral R dm divided by integral dm. So it is a summation only, but summation of infinitesimally small quantities. Since given system such infinitesimal small quantities are very large in number, therefore summation becomes integration. We use integration method to determine the center of mass of continuous mass distribution. This is the formula. Similarly, we can also calculate x coordinate, y coordinate, z coordinate by the same procedure. Therefore, xcm is equal to integral x dm divided by integral dm. If m is the integral dm is the total mass of the system, therefore we can write as r dm position vector. Similarly, as integral dm is total mass, 1 by m integral x dm we can write. Similarly, y coordinate is integral y dm, z coordinate is zcm is 1 by m integral z dm. So by using these formulas, one can determine x, y, z coordinates of the center of mass of continuous mass distribution. Now we will take up one by one example and determine the center of mass of the system.
ఆసక్తికరంగా సాగుతున్న ఫిజిక్స్ ఈ క్లాసెస్ లో ఓ చిన్న బ్రేక్ తీసుకుందాం. బ్రేక్ తర్వాత మెకానిక్స్ లో మరిన్ని అంశాలను తెలుసుకుందాం. కీప్ వాచింగ్ KAB టెలివిజన్.